Hi friends, so far in the previous videos we discussed about the internal combustion engines, the various critical parts fitted in the engine and their job. We also talked about the critical systems of the internal combustion engine, the critical systems like the cooling system, air intake system, lubrication system, fuel system convention and fuel system electronics. We also talked about the tappet setting in the engine. This series I will be covering on the automotive power transmissions. The automotive power transmissions series will cover the components involved in transmitting the power from flywheel, that is from the engine to the wheels which is moving the vehicle. These components including the clutch if it is a mechanical drive, the torque converter if it is a hydraulic transmission, then the manual shifting transmissions, the automatic transmissions, then the differential, axles and the final drives. These are I will be covering in this series. In this video of this new series, that is automotive transmissions, I will be covering on the simple machines and the simple mechanics which we are observing in our daily life, because it is essential to understand the purpose and the job of the simple machines to have clear understanding about the role or the function of the gearbox in a vehicle. Okay. I will be also covering about the torque and the speed in this video. Friends, before talking about the transmission or the gearbox in a vehicle, let us spend few minutes on these slides which explains about the simple machines or the simple mechanics in the mechanical engineering. Observe this figure. This man is lifting a very heavy boulder with the help of the lever. The force applied by him is much lesser than the boulder being lifted. A person is driving out the nail with the help of the forked hammer, applying the force at the end of this hammer handle. Loading a heavy load in the truck with the help of the inclined plane is not directly lifting, but he can perform this job with the help of an inclined plane. Drawing the water from the well with the help of the pulley and rope. Climbing or boarding an aeroplane with the help of the ladder, what we will see regularly. Here one more method of boarding the plane. The difference between these two, you can see the effort required by these people in climbing the plane or boarding the plane is comparatively lesser than the effort required by these people who are using the staircase. The simple difference is that the distance traveled in this ramp is higher than the distance covered through this ladder. Okay. Most importantly, the more the distance to reach the height, the less the effort. Our ghat roads also is an example of this thing. Instead of straight away climbing the hill, there will be large ghat roads with hairpin bends and all. The simple formula is that to climb any height, if the distance is more, the effort requirement will be less. Here also, if we apply the effort with the help of a lever, if still this lever is having further more length, and the requirement of energy will be further less. These are called simple mechanics. We can see basically there are 6 types of simple machines in our regular life. This is a kind of inclined plane, what we have seen in the last slide. A person was using to load an object. This is the lever a person was using to lift the heavy boulder with his low personal effort. This is the wedge normally used to split the trees. Okay, this is the wedge. This is also a kind of simple machine. This is the pulley and the shaft used to lift the loads. Okay, this is the pulley which is also used to lift the load in some other applications. This is also a tool, screw jack, used to lift the loads, trucks, etc., etc. How we are getting the benefit? I mean benefit of using the minimum energy lifting the heavy load. We will just discuss about each and every type of the simple machine. The benefit is nothing but here it is called the mechanical advantage. IMA is nothing but ideal mechanical advantage. For example, what is the mechanical advantage here? Means the length of this plane where the load is being pushed divided by the h. Suppose this is around 2.5 meters. The height is around 1 meter. The 2.5 divided by 1 is the IMA, means 2.5 is the ideal mechanical advantage by using this inclined plane. Here, in this case of lever, suppose this is 4 meters and this is 1 meter. This is E is nothing but effort applied here, force applied at this end, or is nothing but this is the resistance. The force is being lifted here. Force applied to lift this load. F4 is nothing but the load with this smaller distance or with this height, whatever may be. Okay. Here the mechanical advantage by the length of this lever from this pivot point, that is LE, at the end of the effort applied, divided by the length of the lever where the load is being lifted, LE divided by LR. This is suppose 2 meters and this is suppose around 6 meters. 6 divided by 3 is nothing but 6 divided by 2 is nothing but 3 is the mechanical advantage. So if you want to lift 30 kgs load, you can just apply 10 kgs force here. So that's what the simple formula is. The mechanical advantage, the power in is equal to the power output, right? Again, what is the power input? This distance into the effort or force applied. Power out is nothing but this distance or the vertical distance which is the load is moved into the mass of the load. When it comes to the wedge, the mechanical advantage is the length of the wedge driven and the width of the object split. Suppose you drive up to here, the splitting will be to the effect. If you drive up to here, the splitting gap will be this much. Drive up to here, the splitting gap will be this much. The length L divided by this T, the width of the splitting of the object. This is the mechanical advantage of the wedge. Same way the mechanical advantage of the shaft and pulley is the shaft diameter will be less where the load is tied, and the pulley diameter will be more where we are putting our efforts to lift the load. Again, this R radius, bigger R, small radius. This is 4, this is 1, means 4 divided by 1. Same way there will be a formula for this compound pulleys. Same way when it comes to the screw jack, so you have to see the distance covered in one revolution of this lever. So distance covered by this lever. Suppose this lever you consider as the radius of a circle. Okay. The distance covered means perimeter of a circle. The formula is 2 pi r. Here r is nothing but the L. So the distance covered by this lever, that perimeter, divided by the distance the screw jack, the load is lifted. What is the distance? That is the pitch thickness. That is the pitch of this screw. So always the mechanical advantage in the screw jack will be much higher. That's why people use the screw jacks to lift the heavy loads. In the olden days, you might have seen the trucks were being lifted with the help of the screw jacks. So many industrial machines. So the highest mechanical advantage you will get in the screw job. If the pitch is still further thinner, still there will be mechanical advantage will be more. Why we are explaining about all this mechanical advantage and simple machines in this subject is this is very important in understanding the transmission, the purpose of the transmission in the vehicle. See, this is the gears. We all talk about the loads, pulleys, etc. etc. Here, example, this is the drive gear and this is the driven gear. A drive gear is consisting of the 8 teeth, whereas this is having around 24 teeth. Okay. Effort required to move the vehicle will be depending upon the force available at the output shaft of the gearbox. That's why we are explaining, we are talking about all these mechanical simple machines. So here the mechanical advantage is 24, that is number of teeth in the driven gear divided by the number of teeth in the drive gear. 24 divided by 8. The mechanical advantage is 3. See some more gears here. This is driver gear, this is the driven gear. 75 by 25 is equal to 3. The mechanical advantage here also the torque is more because the input speed is much higher than the output speed. Same way 40 divided by 20, the mechanical advantage is 2. Here also the torque is more, slightly lesser than the first figure. In this phase you can see the driver gear's teeth is more than the driven gear teeth. So the driver gear is having 30, whereas driven gear is having only 20. So definitely the driven gear speed will be more, whereas the mechanical advantage will be less. The mechanical advantage is 20 by 30, output divided by input. It's only 0.67. Here the mechanical advantage is less than 1. Less than 1 because the output speed is more. So on a whole, the fundamental rule is that one, the torque is inversely proportional to the speed. If the speed is more, torque will be less. If we want more effort or more torque, the speed should come down automatically. That's why to minimize the speed as and when required, the gears are used. Further formula is that one, if the mechanical advantage is greater than 1, in these two cases the mechanical advantage is greater than 1. In this case the mechanical advantage is lesser than 1. If the mechanical advantage is greater than the 1, in these two cases the output force is greater than the input force, but the distance moved by the load is less than the distance moved by the input force. And in this case, that is, if the mechanical advantage is less than 1, the output force is less than the input force, but the distance moved by the load is greater than the input force. That's why here the speed is less, here the speed is more. Okay? This is the basic principle. Now let us look at this truck chassis. This is the engine and these are the wheels which moves the vehicle. So the power from the engine is being transmitted to the wheels, but in between there are so many components involved in the power transmission: the clutch, the gearbox, universal joints, propeller shaft, differential, axles, etc. etc. Right? Now we will discuss about the gearbox and the clutch in this chapter. This is the car, the engine, whatever is fitted in this car, the speed of the engine and the power of the engine remains same. Certain limitations are there. So, but you need to drive this car on the plain roads, on the gradients, on the ghat roads, and also in rough terrain also. So the efforts or the energy required to drive the vehicle in various road conditions will keep on varying. That is point number 1. Point number 2, any object, whether it is a car, any object, if you want to move from the resting stage, you need more force, you need more torque. See, these people are pushing a car which is in the resting stage. As it starts moving, because of its inertia, it starts moving and the requirement of the energy will come down. So when it travels in the plain road, the requirement of the pushing energy gradually comes down. Again, during traveling, when you come across a ghat road, okay, again the requirement of the energy increases. So here you need to increase the torque. Okay. Same way in this kind of hilly terrain. So what I would like to tell here, we need to vary the torque at the wheels depending upon the driving conditions, and the road conditions. How the torque variation takes place. What is the device installed in the car or the vehicle to vary the torque? That device is nothing but the gearbox. That's what we are going to talk about in this chapter. What is meant by torque? Torque is nothing but, this is the rotational force. Suppose this is the point, center point. Take from this axis, this is a kind of lever. You apply some force. This force multiplied by this distance is nothing but the torque. This is measured in Newton meters, kg meters, foot pounds, etc. etc. Because force applied is kgs or lbs, the distance is in feet or the meters. Okay. The torque is nothing but the rotational equivalent of the force. This we have explained already. This also we have explained. This is the direction of the gears between input and output. Suppose this is the input drive rotating the clockwise, the output is in anti-clockwise. You want the output in the same direction, you need to install an intermediate gear. This is clockwise, the immediate gear is anti-clockwise. Again the next one is the clockwise. If you want to get the output in the same direction of input, you have to install the intermediate gear. This is also same way. But here the speed difference between the input and output is much higher here. Here the speed difference is comparatively lesser. Because of this, two gears are fitted in the intermediate shaft but to the same shaft. This is another animation of the output and input being the same. Friends, this is about simple mechanics and how this formula applies in the gearbox to increase or the decrease of the torque depending on the road conditions. The next video we will discuss about an important component which is ahead of the transmission, that is between transmission and the engine, that is the clutch. We will be talking about the mechanical clutch initially, next video. Please go through these notes. In case there is, you can contact me through the email.